That's a good start, isn't it? Hello, everybody. Good evening, or good day, or good morning, good afternoon, wherever you are. Today, we are going to be looking at distributions. We are going to be looking. I've kind of already looked at this actually in previous videos, but this is a video dedicated entirely to distributions. No, I'm going to keep it on. I'll do what I want. So. Yeah, that's pretty much it, to be honest with you. So there's three types of distributions. Now, if you have looked at this at other videos, hopefully you should carry on watching this because there's actually a lot more to do with this. So this is what we're going to be going through today. We're going to be going through the three main types of distributions: positive, negative, and normal. We're going to be looking at where the mean, median, and mode are for all of them. And that is also added on to the ceiling and the floor effect, both of which I haven't covered before. And lastly, what we're also going to be looking through is actually how this may come up in a question. Okay, so to be honest, I actually really like distributions. I don't know why I like teaching it. I don't know why it appeals to me so much because it is a bit weird. Students tend to struggle on it, and I don't really understand why. Now, this is a normal distribution. You can tell it's a normal distribution because it's equal on both sides. The peak is in the middle, and I guess it's useful to know how this comes up. So there are a few human characteristics which, if you took them from, say, a representative sample of, say, 100 people, that they will always demonstrate this graph. Height. If I took 100 random people, and it has to be truly random, not me going up to them and asking them because I can see their height, I become biased. But if I took 100 normal people, completely random, I would get this graph time and time and time again. You have the majority of people that are in the middle. What's worth knowing, by the way, is 100% of the population is below this line, right? So 100% of the population is below this line. And you'd get a few people that were freakishly tall, and you'd get a few people that were freakishly small. Freakishly is probably a horrible way of putting that, but I can't think of any other better way. So a normal distribution can be seen in a few human behaviors: height, weight, foot size, IQ, for example, motivation. Maybe, probably. If I interviewed 100 people about their motivation and tested it in some empirical, observable, falsifiable way, I think I'm going to get an average. I think there's going to be a few people that are abnormally motivated, and some people that are abnormally unmotivated. So maybe not among teenagers, admittedly. Now, what do you need to know? The mean, median, and mode are right here. The mean, median, mode are along this line right here. Why is the median here? Because you've got 50% in this side and 50% that side. Same thing for the mean, same thing for the mode, right? So, and the mode, by the way, this is a very important thing to just draw. The mode is always the top point of the graph because it is the most people that kind of scored that. It's the most common score. So the mode is always the top part of the graph. Now, chances are you're not going to get normal distributions, right? Because you're not looking at height, weight, IQ. What you're probably going to get is either a positive or a negative distribution. So a positive distribution is when the distribution is skewed to the left. It means that generally people have not scored highly on whatever it is you are scoring them on. So down here would be your, let's say your scores. If you scored down here, you've scored highly. If you scored down here, you've scored lowly. lowly. Um, Generally speaking, as you can see, most people have scored towards the lower side of the graph, meaning that actually people have not performed well in this test. Now, this distribution is experiencing what we call the floor effect. This here is a solid line, right? You can't get a graph. Oh, sorry. You can't get a graph here that's a little bit like this. Let me just show you. You can't get a graph like this. Graph can't go like that, right? Because this line is a solid line. You cannot pass through it. So because people have done so poorly, I'm going to try to do it that way. Because people have done so poorly, what you're seeing here is people crashing up almost and squashing, bulging out that mode a little bit. So this is experiencing what we call the floor effect, meaning that the scores are bunching up towards the lower end, basically, because people have done so poorly. So, for example, if this was a test out of 0 and 20, you cannot get lower than 0. So how I would get you to talk about this is the positive distribution tends to see the floor effect because the scores are bunching up towards that lower end. The odd, the very rare high scores down here, what they are doing to the mean is they are dragging this mean down here. The mode doesn't change. These freakishly high scores don't affect the mode whatsoever. They slightly affect the median, and you do need to understand why. If to demonstrate, just write up random letters. So, if you want to see how the median slightly changes, write up in order 20 numbers, right? Work out the median. And then I want you to add a big fat outlier on the end of that and see what happens to the median. So it does change, but it only changes a little bit technically. It's the mean that is getting dragged down. And that's why you need to know the order, by the way, of positive distributions. You need to know that the mean is the top part just here. You need to know the mean is the top part. And you need to know median in the middle, followed by the mean is the one that gets dragged down. So you need to know it in that order. Flipping that round is negative distributions. So negative distributions are when people have actually done quite well. So negative distributions are, as you can see just here, they are typically done when people are scoring high in a measure, or maybe the measure is too easy. So if I were to give you right now your SATs exam from year 6, if I were to give you your SATs exam from the year 6, I'm hoping we would see what is called the C. Oh, hold on. Sorry about that. So if I were to give you your year 6 stats test that you sat in year 6 right now, I'm hoping that we would actually witness a graph that looked a little bit like this. You're going to have most people doing well. You're going to have most people scoring towards the higher end of the score. You're going to have a few people that didn't do any year 6 revision and thought they could just walk into the test and nail it, and they score worse than they did in year 6. This is experiencing the ceiling effect for the same reason. Let's say the score is out of 20. You can't get 22 out of 20. So these scores, that is a solid like ceiling, if you will, out of 20. You cannot get beyond that. You cannot get 21 out of 20. You cannot get 22, 24, 30 out of 20. And so these scores are basically just bunching up against that higher limit. So again, but you need to know the contextualization for why this might happen. The test may be too easy, right? So make it harder. The gap between learning the material and recalling it was too small. So make it bigger, for example. Maybe the students knew what was in the test. I said, don't tell them. So you need to know that basically. You need to know how you would actually make this a bit better. Likewise, mean, median, mode are in the same order, but down the opposite direction, because again, these people that didn't revise, these naughty little people, are dragging this mean further and further down, essentially, dragging the mean further and further down. And that's negative distributions. It really is that simple. Now, excuse me. This is how you're going to get asked this question. Imagine the graph to the right demonstrates how your class did a recent social influence end of topic test. You've smashed it. Well done. Congratulations. However, the teacher concludes that the test was not a good one and actually decides to be a bit of a furor about this and decides to give another one. This is how you're going to get this question in the exam. Give 2 things the teacher can do to ensure she achieves a normal distribution, getting this graph to move slightly over to the left, and so it's more like this more than anything. How can you move that graph further down? And you would give the suggestions that I've just told you. She doesn't tell the students there's a test. She makes the test a bit harder, for example, so on and so forth. And there are some suggestions just there as well. So that is pretty much it, to be honest. That is it for distributions, and that is it mostly for paper one, for paper one actually. So I think that's pretty much all of it. Make sure you are filling in all of your paper one materials and get ready for paper two.